Hi everyone, today we're going to do a quick review on how to simplify radicals. So here are the steps on how to simplify a square root. So first you're going to take the number under your square root, which is called the radicand, and you're going to find the prime factors. So you do this by making a factor tree, and you essentially keep factoring until you can't factor anymore. Then you're going to circle pairs of prime factors. Remember, pairs are groups of two. For each pair that you circle, one of those numbers is going to quote unquote escape outside of the square root sign. So this is the process for simplifying. However, it is important to note that if you find your prime factors and there are no pairs, that means you can't simplify, and that we will call that a prime number. Okay, so let's give these a try. For this first one, we have the square root of 18. So remember, we're always going to start by finding the prime factors of 18. So you can start with any two factors that you want. Maybe you see 3 and 6. Maybe you see, let's do 2 and 9. So since 2 is a prime number, I'm going to circle it so I remember that I'm done factoring. However, 9 is not a prime number. I can factor that into 3 times 3. Now 3 is a prime number, so I'm going to circle both of those. Now I'm going to list my prime numbers inside my square root sign, 2 times 3 times 3, and then go on to that next step. I'm going to circle my pairs of factors. So I see a pair of 3s. So for this pair, one of them is going to escape outside the radical. But you'll see that I still have a number left inside. I have a 2. So my final answer is 3 times the square root of 2. Okay, let's try this next one. Here we have the square root of 48. So I'm going to start by doing a factor tree. Again, you can start with whatever two factors you want. Maybe you know that 48 is 4 times 12. Now, neither of those are prime, so I'm going to factor more. Well, I know 4 is 2 times 2. Those are prime numbers, so I circle so I know that I'm done. Okay, let's see. 12, let's do 2 times 6, and 6 can be factored a little bit more, 2 times 3. So now I'm going to take those 5 prime factors that I've circled, and I'm going to list them inside my radical. So 2 times 2 times 2 times 2 times 3. And if you did this multiplication, it should equal 48. Now here you'll notice that I have 2 pairs. I have a pair of 2s here and another pair of 2s. So for this pair, one is going to escape out front, but I have another pair. So another 2 is going to escape out front. Notice that I put parentheses around them because I will multiply those two values. Now let's see what we have left inside our radical, just a 3. And 2 times 2, of course, is 4. So our final answer is 4 times the square root of 3. So this is the simplified version of square root of 48. Okay, let's look at the square root of 30. So let's start with our factor tree. We can do 3 times 10, so 3 is prime. 10 is just 2 times 5, which are both prime numbers. So let's list out our prime factors. I like to go in numerical order from smallest to largest, but you don't need to. So 2 times 3 times 5. So if you notice here, we actually don't have any pairs of factors. So that means that we actually can't simplify this radical. So the simplified version of square root of 30 is just square root of 30. That's our answer. Okay, one more here. So let's start factoring. So this number is a little bit larger, but any number that ends in a 5 will always be divisible by 5. So we can do a little long division on the side. 5 goes into 6 one time. 5 goes into 12 2 times. And 5 goes into 25 5 times. So 5 times 125. So again, we have a number that ends in 5. So I'm going to divide by 5 again. So we'll do our little long division on the side. 5 goes into 12 2 times. And 5 goes into 25 5 times. So 5 times 25. 25 is not prime. It is equal to 5 times 5. So our list of prime factors is 5 times 5 times 5 times 5. So I see that I have a pair of 5s here and a pair of 5s here. So from this first pair, one escapes, and from the second pair, another one escapes. And what you might notice is that we don't have any numbers left alone inside our square root, which means our square root sign disappears altogether. And our answer is just 25. So whenever you have a number where the square root disappears altogether, it's because 625 is actually a perfect square. So it's okay if your radical sign disappears and you have nothing left. Just make sure you don't write it anymore. And again, that just means that the number you were taking the square root of is a perfect square. Okay, go ahead and pause the video and see if you can give these 3 a try. All right, let's check our answers here. So for part A, our prime factors are 2 times 7 times 7. And with a pair of 7s, that leaves us with 7 times the square root of 2. For part B, our prime factors are 2 times 2 times 2 times 3 times 3. Notice that I tried to put them with the same type of numbers. So I have one pair of 2s, one pair of 3s. So a 2 escapes and a 3 escapes. But I still have a 2 left inside my square root. And 2 times 3 is 6. For part C, my prime factors are just 5 and 7. There are no pairs, so that means that the simplified version of square root of 35 is square root of 35. It was already simplified. And for part D, now this first step might have been tricky. It might have been hard for you to figure out what you can divide by first. But of course, if it's even, if your last term is even, we can always divide by 2. So we could have started off with dividing by 2, but here I tried dividing by 7 and it worked, so 7 times 28. And that means that when I was done factoring, it was 7 times 7 times 2 times 2. I have a pair of 7s and a pair of 2s, which means that there are no numbers left inside my square root, so the square root sign disappears. What I have left is 7 times 2, which is 14. All right, that is all for today's lesson. Thank you so much for watching.